All right, what does it mean when it asks you to find the domain of a function or of an equation? And remember, domain are basically it's asking you what can you plug in for your x values that would work. So I always ask the opposite. What can I not plug in? Okay, and there's really what we're dealing with. There's only two times you have to be careful. You have to be careful when there's fractions because remember you can't have a zero in the denominator. And you also have to be careful when we take square roots because you can't take the square root of a negative. So those are the only times that you need to be super duper careful. So let's look at this. I don't care about the numerator. You can have a zero up here, okay? All I care about is down here. So if you can't see that this can't be 3 because 3 minus 3 would give you 0, then set this equal to 0 and solve. So you can see here if I add 3 to both sides, I get x is 3. So basically, I could plug anything into this equation and it would be happy except 3, okay? Because that would give me an undefined fraction. You can't have 0 in the denominator. So what does your domain look like? Well, I can use everything negative until I get to 3. So that's why we use the parenthesis, because I can use everything up to 3, like 2.999999. And then union, because I'm going to pick up right after 3, like 3.0 whatever, to infinity. So this right here is your domain in interval notation. That says everything but 3. So we're going to do the same thing again over here. Nobody cares about the numerator. It's the denominator. We can't have x to be 5. And again, you can set this equal to 0 and solve, but x can't be 5. So your domain is everything but 5. So I'm like, okay, well, I can have everything negative until I get to 5. You use a parenthesis that says I can't use 5, but I can use everything really close to 5. And then we pick up right after 5 and go to positive infinity. So again, this is everything but 5. Notice what this looks like. They're consistent. Okay, I did this one. Again, x can't be 0 because you can't have 0 in the denominator. So it's everything but 0. So it's going to look like this. Union 0 to infinity. Okay, this would look like everything but 0. All right, now I just threw this one in here. There are no fractions, there are no square roots. It's just a nice little quadratic equation. I could put anything I want in here. I can put zeros, I can put not positives or negatives. So my domain is everything, all real numbers right there. So that's what that one looks like. Okay, square roots. Remember under here, you can take the square root of 0. That's okay, because 0 times 0 is 0. So you need this value under here to be greater than or equal to 0. So I could put 0 in here or anything positive. You just can't take the square root of a negative or you don't get a real value. And we're only dealing with real numbers right here. So this domain looks like 0 because you can use the 0 all the way up to infinity. Okay. Now, what about this one? This has to be greater than or equal to 0. So you can come down here, and if you can't see it, you can solve it, but add 7 to both sides. So I can see x has to be greater than or equal to 7. So that's what I can plug in. So I go from 7 to infinity. That would be my domain in interval notation. Because it has this or equal part, then it's got this bracket right here instead of the parenthesis. Okay, this one maybe it's a little harder to see, but I'm going to take what's under there, set it greater than or equal to 0 and solve. So if I subtract 5, I've got 2x is greater than or equal to negative 5, and then divide by 2. So I can see x has to be greater than or equal to negative 5 halves. So what does my domain look like? It starts at negative 5 halves and then everything bigger than that. So all the way up to infinity. And if you'll notice, there's always parentheses every time you use an infinity because you're never going to get there. There is no stopping point. Okay, last one. This one's a little tricky, so I saved this one for last. But again, set it equal, greater than or equal to 0. I'm going to subtract 2 from both sides. Be careful here because you have this. Don't forget, that's still a negative. But I don't want to solve for a negative x. I want a positive x. If you change the sign of one, you change the sign of both. But also remember, if you change this sign, you have to change this sign. You could also think about the fact that you're dividing both sides by a negative 1. And remember, when you divide by a negative, you got to flip this sign. So be careful when you write your domain. This is saying I can use 2 because it can equal 2, but it wants everything smaller, less than 2. So that means I'm shooting down here to negative infinity, and I'm good up to 2, bracket, because I can equal 2. So that's your answer on that one. So enjoy.